Hello everyone. In this video, I'll be going to discuss the third problem in RMO 2023, the exam which was held today. So, talking about the problem, so the very first thing you can notice is that, like again, it's a number theory problem. The first one was also a number theory problem. This one as well. So, what is it saying? That Sn denote the sum of the digits of n. So it's Sn is the digital sum. Now find and also like you are working in the decimal system, so base 10. So yeah, so nothing really matters here. So the usual thing, so find all natural numbers m and n such that m is strictly less than n and Sn square is equals to m and Sm square is equal to n. Okay, so this m less than n is nothing, like once you find a pair, I mean, if they are equal, then you can't consider it. Like there is an example like 81. Okay, so for 81 you will see that if you take n to be 81, okay, so 8 plus 1 is 9, 9 square is again 81. Okay, so I mean both are coming out to be the same then, so then that won't be considered. So for the rest of the examples, if you are getting, so one will be lesser than the other, and so since it's symmetric about m and n, so you can take one to be, the smaller one to be m and the larger one to be n. But now talking about how we can attack this problem. So the very first thing that one can come up with is like the sum of the digits of a number, of a natural number. So always that is like, I mean, congruent to the number. Okay, so when you take any natural, like let's take any natural number n. Now you do I mean, you expand it. Okay, and expand it 10 to the power k a k plus 10 to the power k minus 1 a k minus 1. So you expand it, take it under modulo 9. You'll see that you are getting the sum of the digits. Okay, so any number is congruent to the sum of the digits under modulo 9, even under modulo 3 also. Okay, so if you go in that direction, I also tried it first in that direction, but things did not work out. Why? Let me explain a little bit. So here, like what you are having is that Sn, okay, so Sn will be congruent to n modulo 9. Okay, and then what else do we have? We have that Sn square is congruent to n square modulo 9. Okay, but here then what happens is that, like we know that Sn square is m, so that means m is congruent to n square modulo 9. Okay, now similarly, in a similar fashion, you will get that like what Sm is congruent to this m modulo 9, and if you square both the sides, then again, so if you again square both the sides here, so from here we are getting that m square is congruent to n to the power 4 modulo 9, right? And again Sm square, so from this Sm square, which is n, is congruent to m square modulo 9. But finally, if we take the help of both of these, so that would imply that n to the power 4 is, or n to the power 4 minus n is congruent to 0 modulo 9. Now after getting this, you will, I mean, in an exam hall you will be very happy that you have got such a nice expression involving n. Now you are very happy that okay, I'll factor it out and use some apply some number theory, and I'll be able to get n. But what happens is that after factoring it out, like there would be three factors, right? So n minus 1, and then n square plus n plus 1. So first you will take that 9 divides n and so on. So then also, like the next step is like a trial and error. Okay, so that way also, like you can go. Okay, but again it will be a trial and error. But again, the way I am also approaching, finally again it's a trial and error at the end. Okay, so the main objective here is like first we will try to bound it. Okay, So now let's look at it, how we can bound it, and then I'll do the generalized expression, okay, the generalized bound. So what happens is that let's take a 4-digit number, okay. So a 4-digit number which will be like greater than equals to, so I'll work with a smaller one, okay. So I have been given that m is m is strictly less than n, okay. And also try to notice that here m is strictly less than n, and whatever the digital sum is, whatever, it's a natural number again, so you're squaring it up. So here m is also a perfect square as well as n is also a perfect square, okay. So that also excludes a lot of the natural numbers, okay. So you don't have to check even while you're going doing trial and error, so you don't have to check one by one all the natural numbers. You can just go on with the perfect squares. So what happens is that both are perfect squares. So again, what happens is that if m is strictly less than n, which is given, okay, and we are considering that I'm working with the smallest one, m. So m is greater than equals to that is 1000, okay. Though 1000 is not a perfect square, but yeah, so we can say that m is strictly greater than, okay. So m is strictly greater than 1000, whatever. So the main point being here is that let's try to show that, like, if m is a 4-digit number, then I won't be able to get any such n which satisfies the condition. So how? So now try to think that if m is a 4-digit number, so how do I, if I know m, how do I get n? That is the sum of the digits of m, then square it, right? So now try to think that what is the maximum Sm. So that is basically like 9 plus 4 digits, right? So 9 plus 9 plus 9 plus 9, which is 36. So 36, okay. So now whatever is n, so it's like either 36 square or 35 square, whatever is n, okay. Because Sm, I'm squaring Sm to get n. So Sm, m for mango, Sm can be 36 at most. So that means 36 square. Then if Sm is not 36, it's 35, 35 square. If Sm is not 35, then 34, 33 and so on. Now like this, try to understand that Sn is either 36 square or 35 square or 34 square. Sm square, which is n, and then 33 square, and then we have 32 square. But then what? Then we can't go below that, okay. Because why? Because if I go to 31 square, then it's already n is becoming a 3-digit number, right? So I mean, there is no way that like I can n should be greater than m. So if m is a 4-digit number, so n can't be a 3-digit number, right? So now let's check that. Now let's see that 36 square, okay. So how much is 36 square? 1296, okay. So like for this I get 1296, okay. So just try to think that, I mean, whatever is n, okay, even though suppose I am thinking that okay, there is some solution, there is some n which works, a 4-digit number n works, so n will be less than or equal to whatever, 1296 is also perfect square, whatever, okay, is less than equals to 1296, okay. Now I also know that to get m from n, so now to get mango from Nagpur, okay. So the thing is that, like, how do I produce m, that is Sn square will be m. Now think that what could be, if this is the situation, what could be Sn. So if this is the situation, so max Sn is less than, strictly less than, like the first digit can't go more than 1. So whatever you square the rest, it's all going to be going to go down. So the first digit can't exceed that, okay. then the second digit, okay, the second digit, even if I make it like 3 or whatever, it won't exceed, but still if I make it 3, and then the next two, if I make it even 9 also, okay, so then also you see 9 plus 9 18, 18 plus 4 is 22. So 22, that is max Sn. So that means Sn square, which is like either it's 22 square, 21 square, whatever it is, it's not reaching this 4 digit. It's not being greater than 1000. So that means like from this n, we are not going to get to m, okay, if such a solution was there. So we are not even able to get like we are not able to exceed 1000. So that shows that there is no such solution for this 4 digit numbers, okay. So now from 5 digits onwards, try to understand from 5. I mean, here we had a little bit of like this thing, like you would understand what I want to mean. Like, let's go to 5 digit numbers, okay. From 5 digits, it will be very, very clear. Why? Because even if I take that, okay, suppose now talk about 5 digits. So m is a 5 digit number, okay. So that means it's greater than equals to 10 to the power 4, okay. So now what could be max Sm? That could be 9 times 5, which is 45, okay. So now you see that, like, I mean, you just square Sm to get n, right? So you just simply square 45, okay. So where do you reach? You are very, very, very far away from 10 to the power 4, right? So I mean, so that means Sm square is strictly less than or less than equals to 45 square, okay, and 45 is strictly less than 50. So I can even say that this is less than 50 square, and which is like, you can very well say that 2500, okay, which is way lesser than 10 to the power 4. So n should be greater than m, right, according to our condition. So from here onwards, things become more and more clear, okay. So then so now to get the full marks, we should like, now if you leave it here and say that similarly for others, like for higher powers, we can easily show that. So some marks would be deducted, right? Still, like, we should make this thing, we should get a generalized something, right? We should make this claim. If this claim is true, then obviously we should be able to prove it, okay. So in mathematics, nothing is very trivial, okay. We always, like, everything we should make it like prove it, okay. So yes, so the thing I was saying, like, here why things become very easy, like even for the maximum sum, the square is not being able to reach 10 to the power 4, but here there were some cases like 36 square is still more than 10 cube, okay. So that's what I wanted to mean. So now I'll be making a claim, okay, which I'll be proving. So the claim is that yes, then okay, so let's say that m is a k digit number, okay, where k is greater than equals to 5, okay. So my claim is for greater than equals to 5, because for k equals 4 I have shown, and for k equals 1, 2, 3 I'll go later on, okay. So k greater than equals to 5. So yes, I claim that there is no such solution. Now what should I come up with? So this process, what I did for 5, I tried to generalize it, okay. So how do we generalize it? Try to see. If m is a k digit number, so then again, what is max Sm? That is 9k, as simple as that, k digits. So you add 9k times sum is 9k, right? Now you are going to get n by squaring Sm, right? So that means n is strictly less than or less than equals to 9k squared. Okay, so either n is like 9k square, 9k minus 1 square, 9k minus 2 square, and so on. Okay, so whatever it is, it's less than equals to 9k square. So which is 81 k square. Okay, and which I can say that it's less than 81. I can say that it's less than 100. Okay, so 100 is 10 square multiplied by k square. Now see how I generalized it. So try to think, like always backward calculation. So here what my idea was that here what I showed that Sm square, which is n, okay, is being less than 10 to the power 4. Okay, so I mean m is m for mango. M is a 5-digit number, so it's greater than equals to 10 to the power 4. So if I show that n, so I was able to show that n is strictly less than 10 to the power 4. So here my idea is that to show that this product, okay, this is strictly less than 10 to the power k minus 1. Okay, this is I want to show. This is my claim. So now try to think back, try to backtrack and think that then for k what condition should I input? Okay, if I want to show this, then my claim would be that this thing, that is k square is always less than this thing, that is 10 to the power k minus 3. Okay, so that we multiplied with this, and of course k is greater than equals to 5 and k is a natural number. Okay, so this is my claim. So if I want this, then see, if I'm able to show this, I'm done, because m, I have taken it to be a k digit number, and n is, which is greater than m, so I'm finally getting that n is like strictly less than 10 to the power k minus 1. Okay, so whereas like n should be greater than equals to 10 to the power k. I mean equals to also won't be possible, because if m is also 10 to the power k, then n should be greater than that, but try to understand the thing. Okay, so if I'm able to show this, I'm done. So that's why I'm claiming this. Now how do I prove this? One thing is like we can use induction. Okay, like what we can do is like you use induction. Okay, so just a second. Yeah, sorry for the interruption. So yeah, so what we can do is use induction, but yeah, I took log base 10. Okay, because here I was having 10. So yeah, base 10 k. So here I get 2, and if I am taking log, so still the inequality will be preserved, and here I get k minus 1, k minus 3, and that's it. Okay, so I have to prove this. So required to prove is this. So now try to think that again for 5 you can, so the base case is 5. Okay, for 5 you can just plug it in and see that the right hand side is 5 minus 3, which is 2, and the left hand side is 2 times some not even like I mean it's strictly less than 1. I mean if k is 5, so log 5 base 10 is strictly less than 1. So which shows that like this is way lesser than like 2. Okay, so I mean, see if you understood it. Like what I mean is 2 times log 10k is strictly less than or 5. Let's put 5. So 2 times sorry, log 5 is strictly less than 1, so less than 1. So basically we get that this is strictly less than 2. Okay, so base case is done. Now I let it like for k it's true. I'm not writing that. Okay, so trying to save some time. Now for k plus 1, so 2 times log base 10 k plus 1, so required to prove. So this is my hypothesis. Now I am taking this to be true and trying to show for k plus 1. So k plus 1 minus 3. Okay, so now try to understand this thing, that is, let's see. So I have to use my inductive step. So how can I use it? Like I have to compare log base 10 k and log base 10 k plus 1. Okay, so try to understand like let's see what could be like log k plus 1, of course base 10, minus log k. Okay, so this is again base 10, of course. So log base 10 k plus 1 by k, so which is log base 10 1 plus 1 by k. Okay, yeah, so the thing is that this is like k is a natural number greater than 5, so this is like all strictly less than like log base 10, and then I can write here 2. Okay, so what we can very well say that even 10 to the power half is also like 3 point something, right? So we can very well say that like this is less than half or 0.5, strictly less than half. So if I use that, so then I can very well say that log base 10 k plus 1 is strictly less than half plus log k. So 2 times, let's see if it works, k plus 1, this is strictly less than 2 times log base 10 k, and I have there 0.5 half. Okay, and this is coming out to be 2 times log base 10 k plus 1. And now let's use the inductive step, that is 2 times log base 10 k is less than k minus 3. Okay, so that was our inductive hypothesis. So that is less than k minus 3, and I have here this plus 1, and so it's perfectly coming out, as you can see, k plus 1 minus 3, whatever, like still the same. So anyway, so it's working for k plus 1. So yes, that's what I how I did it, but like while just making the video, it came in my mind I could have even gone without log as well. Okay, so anyways, the claim is proved. Okay, so for k greater than equals to 5, my claim is proved by induction. I'm not writing again by induction, this is this and that. Okay, I am leaving it to you. So now what here I am finally getting this thing works. So then for I mean k greater than equals to 5, no solution. So that means if m is having 5 or more number of digits, no solution is possible. I proved it generalized way. Okay, and then coming to the main point, that is then what's next. So we proved that for 4 digits onwards, like no solution. So that means if the solution is occurring, then it's like either in 1 digit, 2 digit or 3 digits. Okay, 1 digit you can simply check, so there won't be any problem to that. So coming to the thing that yes, if it is a 3 digit number, so try to understand that like suppose we have discussed that m and n are perfect squares. Okay, so now even if it is a perfect square, so it's coming from the sum of the digits, okay, sum of the digits square. So now think that if I have a 3-digit solution, okay, if like m is a 3-digit number, okay, so its maximum, again, max sm is what? 27. 9 plus 9 plus 9. So whatever is n, okay, which is sm square, it's less than equals to 27 square, okay. So now we are in a finite range where even you can like just simply go with trial and error, not even trial and error, definite way, like it's just manually checking, okay, not even like trial and error, you can say that definite manual checking. And finally, like what do you have to do? Like 1 square, 2 square, 3 square, till only you have to check the 27, I mean this 27 numbers, okay. Just for the first 10 digits, like you can easily do it, okay, even so those, even if you delete, like you are left with 17. So anyways, that's checking, I leave it to you, so that you can easily do it and check which one is satisfying the condition, and there is nothing else, okay. So I checked it, and I got that like m is coming out to be 13 square and n is coming out to be 16 square, okay. 13 square, which is 169, and 16 square, which is 256, okay. So I manually checked it, might be like in a hurry, I missed, I mean I think I may have missed, but if I missed, just comment below, and yeah, if I didn't, how, also comment below how you like the solution. So try to understand that it's not it's like a subjective question, it's an RMO exam, so it's not a MCQ exam. If you just write, if somehow you got the answer, you write it, you don't get the full marks until unless whatever you are claiming you prove it fully, okay. So that's the whole proof, okay. Anyways, so that's it for this video. So thanks for watching, and keep watching and keep learning, and see you in the next one.